Hello, everyone. We'll talk today about running PostgreSQL on Kubernetes and specifically about the state of this, where it came from, where it is right now, and where it is going. And this will be a rather high-level overview presentation. So first, I think it's very interesting to touch the disconnect what we see in Kubernetes and PostgreSQL and actually other databases space. Where a lot of people would tell, well, Kubernetes was designed as a stateless disposable workloads handler, and PostgreSQL is this like a very sensitive, latency sensitive technology with a lot of hard sharp edges. How are you really going to run them together? And yes, that was true at some point, right? But I think that has significantly changed now. But before we look in the history, let's talk about why do we have a lot of folks choosing Kubernetes and specifically choosing to run data-intensive workloads, PostgreSQL included, on Kubernetes. I think one thing which is great about Kubernetes, it is accessible, available basically anywhere. You can run it on the bare metals, VMs, all the clouds provide you multiple options, including managed Kubernetes services or role you own. You can put it on the edge. You can, run it on your laptop, even on a set of Raspberry Pis, right? And that is very convenient to have sort of at a unified interface. It is also very modern approach compared to other approaches that exist. It really allows team to utilize concepts as infrastructure as a code, GitOps, right? Cloud native approach, right? And that both is modern as well as have a lot of a mind share for some of the teams. And you know what, wherever you like it or not, that is how they would want to run it. I think what is also important is Kubernetes allows you for a lot of automation. Kubernetes provides this unified programmable environment, which with that allows for high level of automation, right? And because software can be polished, it really brings in the end high level of quality with a lot of kind of edge cases gradually being handled and worked on, right? And that is a very different compared to some other approaches people have. Then they would implement some of a custom automation, which is kind of has to be slightly different in different environments, right? Or really struggle if something's manual, right? Like for example, classically you would have, well, I have this, let's say, PostgreSQL cluster. One of the nodes has died and it's kind of unrecoverable. Now I have to figure out how to provision a new node. But my programmable interface doesn't have a concept of that. It's kind of sort of like a physical action in a sort of like a legacy world. With Kubernetes, well, you know what Kubernetes ensures, if one of the nodes handled, you get another one. And then I think there is an outstanding community around Kubernetes, right? And of course, around Postgres as well. The cloud native computing foundation pushes forward everything which is around for Postgres. There is the data on Kubernetes community, right, which is really focuses on specifically running data intensive applications on Postgres and so on. Now, with that, let's dive into the history of Kubernetes for data-intensive applications and, of course, PostgreSQL specifically. If you look at the start of Kubernetes, that started in 2014, now more than 10 years ago. And that was indeed a solution which was designed for stateless workloads, right? And I think with that is, of course, is very far from where we want the databases to be. Now, since that, it kind of having been marching forward to have better and better support for data-intensive applications. And I think that is for a very, very good reason, because this is a very important part of their enterprise, right? Handling the data is, pretty much a very big core portion of computers. Now, if you look at the first thing which required for data-intensive applications come also more than 10 years ago, it is persistent volumes, which enabled early support for durability and persistence. Now you could store different data on those persistent volumes, right? And they would be disconnected from those disposable containers, right? Which when they die, kind of all the data which is stored inside that container disappears. Then, if you look at 2016, that is where some serious work on support for the data-intensive applications started to be worked on. There was a project which was called initially, PetSet, which, I think was quite a nice playful name, but then ended up being in GA what we know as a stateful set, right? Because I guess the pet set is offensive to pets, and that became the foundation to execute complex database operations. Now, why is that important? Because if you think about the databases require much more kind of ordered approach, right? In an application scenario, often if I want a high availability, I can say, hey, I just spin up the 10 copies of my web server, right? And it doesn't matter in what order they came, I just have 10 of them, and they are going to provide me high availability and scalability and so on and so forth, right? In database, that is not how it works out. If you are provisioning the replicated cluster, there is a sequence in which you want to provision that. If something fails, you want to make sure some logistics happens about that. It's not just same copies. We have a different sequence, different approaches, and so on and so forth. Now, the next thing which was important in Kubernetes environment, I think, is the container storage interface, right? Because before that started being introduced, the persistent volumes would be configured and provisioned different ways in a different environments, right? There would be provision for Google Cloud, for Amazon, for VMware, and so on and so forth, right? And that would not be very, very convenient, right? You would have to have a lot of that storage configuration of different features, right, in the different environment. And CSI started to really change that to embrace the portability. Then in 2019, something else came into place, is a support for local persistent volumes, right? And this is important because if you are looking at the very, very fast data access, all those shared volumes which are network accessed, they are not as fast as accessing the data on the local storage, especially if it's the ascent of NVMe and related technologies. And now Kubernetes allowed you to store the data on those distributed network attached volumes, as well access data on those local persistent volumes, of course, with all the challenges what that brings in terms of your data replication and so on and so forth, but empowering certain high performance database deployments which were out of reach before that. Then in 2020, we have volume snapshots, which came into place. And volume snapshots are important because if you look at a lot of enterprise workloads, thinking about, NetApp based and, some other SAN solutions, right? They very much like this approach of snapshots. It provides a lot of benefits, right? You can take very quick backups, very quick restores. You can clone the data if you want to, hey, get a copy of your 50 terabyte database and, to run some tests on it before you move it to production. All of that is possible with a volume snapshots, which now appeared in Kubernetes as well. And the last one, which I would mention of a big innovation, is the online volume expansion. That was also another challenge in some of deployments before that, because if you think about the databases tend to grow, right? And if you cannot resize your storage when you provision whatever storage for a database, and then that volume becomes full, you have to restart your pods, right? That is just messy, not a nice way to do that. Now that is not needed anymore. You can provision your volume to be very small size, so you don't waste on the database space and have it grow as the data scales. With that, let us talk about history of Postgres on Kubernetes. Now, if you look at the first approaches, which was really out there since the first day of Kubernetes, and even before, well, we could spin up PostgreSQL in containers, and now we can just toss that container to run PostgreSQL in pod. And if you just want to play with database for some testing, it was already working, and that was quite usable. But of course, it was not really good for any kind of mission critical production at that point, right? There is no high availability, there is no durability even, and so on and so forth. Then, of course, Helm came into a picture, and we could now provision PostgreSQL better with the help of Helm, make a configuration easier compared to just tossing a container on the cluster, and that made the deployment easier, but it did not really help with the day 2 operations. And I think that is very important to remember. If we are looking at the mission critical production databases, they are often operating in day 2 environment like 99.9% of their life, right? Often a provision database, and it has to stay up for years, if not decades. Yeah, sometimes maybe it has some bit maintenance here and there, right? Or unfortunate downtime, but it always stays up. It's not just, let's say, hey, wiped out and reprovision, as often it is the case with applications. In 2017, we have two first PostgreSQL operators came about. We have a PostgreSQL operator from Zalando and Crunchy Data's PostgreSQL operator, also known as their PGO, which started to really introduce that much better concept of running PostgreSQL in Kubernetes. There you can have a cluster. That cluster provides availability. It has some self-healing primitives and has some, backups and so on and so forth. Now, if you look from Percona side, we only started supporting PostgreSQL in 2018 at Percona, right? So we were not out there in that very early Kubernetes operator game, but we introduced our PostgreSQL operator for Postgres in 2021, and if our focus was on really like a fully open source enterprise grade solution for Kubernetes, right? We based our operator on Crunchy Data operators with some changes, but I think what is very important, it would not be connected to those subscription-only images which Crunchy Data operator had. Now, if you look at a couple of latest years, what has been happening with PostgreSQL on Kubernetes, we have a cloud native PG operator, which was spun up from Enterprise DB, donated to CNCF, and last year it's joined CNCF Sandbox. And I think that is important development, meaning what now we have an operator which is supported by this, official CNCF Kubernetes community, not just by by one of a vendor. And in 2026, just this year, we will also have another significant relevant project for running database on Kubernetes called Open Everest, which joins Zaitsev's sandbox as well. I touch on Open Everest because that was previously known as Percona Everest. That is a project which was developed in Percona for a number of years. We donated that to CNCF. And this project is focused on even kind of high-level usability, easy user experience, right? If you are looking to do something as running the, you look for RES-like experience on Kubernetes, then you can do that. Okay, with that, let's now talk about the current state. What has been going on? One thing is what we do have a choice of mature PostgreSQL operators. Right, we have a variety of options, right? There are many open source options, including Cloud Native PG, managed by Cloud Native Foundation, of course, Percona operators. We have a KubeDB, which offers proprietary operator for Kubernetes. There are some, other options as well. But I think that is awesome that there's like so many choices out there. We also have now a lot of choices for Cloud Native observability. And I mentioned that because operating databases at scale, well, that often means you have to resolve rather complicated problems. And initially, if you look at 2017, 18, the kind of cloud native database focused observability was actually quite weak. Right now, there is a lot of work has been done in this case. There is open telemetry-based solutions. There is exporters for Prometheus, right? There is also solutions as Karoot, right? Which is quite cool. But anyway, I think cloud native observability is covered quite well. This is example what you can see with Karoot, for example, right? Which I think is a very cool for understanding your data intensive applications, where their traffic goes, how applications connect to each other, and there are some failures or data latencies emerge, and doing all of that without any configuration required. The other thing what is going on with PostgreSQL, it's emerging as a database platform, right? Really supporting this effort of platform engineering where many companies employ. And what that means is it really starts to support various specific database-specific policies and templates, right? Often for large environments, there is a lot of specific policies, what they have to do. Like, hey, we always have to do encryption for this level of application. We have to provide this level of reliability. We need to make sure this backup policy happens so we don't lose our data, and so on and so forth, right? Which is one of the features what solutions like Open Everest is strive to provide on the top of operators. Finally, let's touch on the future. Now, one thing we all know, what there is AI is emerging right now, right? It's really disrupting a lot of markets and technology, and I think there is a lot of uncertainty. What the future will look like? There will be, Kubernetes, Postgres, humans. Are we going to have AI become so smart it will throw away all that stupid human-written software and implement something, better, faster, more scalable? Well, these are maybe some of the most possibilities out there, but there are also some which I think are very likely and which are kind of happening right now. One is the concept of self-driving databases, right? Obviously, as humans, we want to spend less time of operating database. We want them to be as autonomous as possible. We have, of course, limitations, what we are not going to go down, lose our data, right? Or so on and so forth, right? And that is something as, again, database is similar to cars. We see that process ongoing. Right now, most of the databases, if you look at sort of like a car, automation and knowledge is somewhere between assisted and partially automated by desire for many companies to get to all the way to that level 5, and we are not quite there. Also, we see what everything is going agentic those days. Well, at least in terms of supporting agentic workloads, meaning is what we are not expecting just the humans directly interact with, or write a code to integrate with APIs or wherever. We are expecting some of the database interactions for provisioning, troubleshooting, some other actions will be done by agents, and that is their database on Kubernetes specifically is involved, because again, that is a very nice automatable platform. I think another thing what we are seeing being evolved with the databases is building the solid foundation. One thing we know about the AI is AI has hallucinations. AI does mistakes. Sometimes it's very strange, unexpected mistakes. And what is being developed right now is this idea, okay, how can we ensure what our database solutions for with a lot of PostgreSQL focus, of course, can be really safe when they are being used by the agents? How can we ensure we are not using our data, expose our data, took some other risky decisions we don't want them to take? So as a final thoughts, well, I guess you got it from the first slide, right? I think that is a great time to run PostgreSQL on Kubernetes. There is a lot of options and a lot more great stuff to come, but also do recognize that is not perfect, right? I wouldn't say like, hey, you can just take every single database and move it to Kubernetes tomorrow, right? There are still works being done, some problems which are being solved. With that, that's all I have, and thank you for joining.